Friends, we are discussing the heat pump technology. In the earlier video, I concentrated on the concept of heat pump, and we said that the heat pump is more efficient than an electric geyser. Uh, some more information would be had in this video. I had titled this video as air source heat pump, and you need to be clear as to what is a air source heat pump. As we mentioned earlier, a heat pump basically takes in heat and pumps it somewhere else. So the heat pump would take in the heat from a lower temperature, which is the surroundings, and it would pump the heat to a space which has to be maintained at a higher temperature, right? So if this is the machine, the heat pump, which does this job, when this extraction of Q, that is the heat transfer, is from the working fluid, from the fluid which is air, then that is called as the air source heat pump. It means that the source of energy is air, right? So we are going to discuss the types of air source heat pumps. As we mentioned in our earlier class, we said that a heat pump is basically a machine which runs on a vapor compression cycle. It means it also has the same components as that of a refrigeration machine or air conditioner machine. Namely, it has got a evaporator. We mentioned that it has got a compressor. It has got a condenser, and it has got some expansion device, right? Now the difference between a refrigerating machine or air conditioning machine and heat pump is that this unit, which is the outdoor unit in a heat pump, what it does is it basically extracts the heat and it pumps it inside this, right? Whereas in case of air conditioner, you know that this unit, the outdoor unit, basically throws away the heat if it is a AC, right? Or even a refrigerator. So outdoor unit function is entirely different in case of a heat pump, or it is opposite to that of a air conditioner. So that you need to understand. Okay, so outdoor unit in case of the heat pump is the evaporator, and the indoor unit is the condenser. So that is a crucial difference between the heat pump and air conditioner. We talked about the coefficient of performance for a heat pump being in the range of 3 to 4, right? And this means it gives you multiple times of the energy input. So if you are supplying 1 kWh, you will get 3 to 4 kWh as the output, right? Which is unlike your other devices like boiler or let us say your electric geyser. So a heat pump is 5 times more efficient than a boiler and 4 times more efficient than your electric geyser. Okay, that you will have to keep in mind. There are two types of air source heat pump. ASHP means air source. The source is the air heat pump. It is either air to air or it is air to water. Now, when you are talking about air to air heat pump, what we are saying essentially is the space from which the heat is extracted is air, right? So this is the heat pump. So it will extract the heat. From the space which contains air directly, and it would pump it to the space which is also air. right? So this is the typical application of room heating, right? So that is the ear-to-ear heat exchanger. So it means that in this case, when you are extracting the heat, your evaporator is located somewhere here, which is outside. And here again, this is a heat exchanger where the heat is it is thrown to the space which is here, and it is again a heat exchanger, but now it is a condenser. So it is now the indoor unit, right? In case of air to water heat pump, right, the space from which the energy is extracted is here, but the space to which the energy is rejected is water. Okay, so you will have pipes running, okay, and these pipes would have water, and the water would get heated. So you will have the heated water as an output from this heat pump. So this heat pump is different in the sense that this indoor unit would have water as a heat exchange fluid, or it means the water gets heated. Here the air gets heated. So that is the difference between this. So you might find that there are radiators which are used, and or there are underfloor heating pipes which are provided, and it provides domestic hot water. So this is also in India, for example, you will find air to water heat pumps mostly used for water heating applications, be it in your hostels or your domestic homes. Domestic application, that is your homes, right? So, and year-to-year heat pumps are also possible in your colder climates, or even in Europe, or in maybe in northern part of India, where you might find a year-to-year heat pump which can be used for heating the rooms in winter, and if it is too hot, it can be reversed to operate as a air conditioner also, to provide comfort air conditioning. Okay, so these are the two types of air source heat pump: air-to-air heat pump and air-to-water heat pump. Heat pumps, their performances would depend upon the temperature of the surrounding. Okay, this space which we are talking about. So this temperature, the space temperature is going to matter a lot in the performance, right? So if you are talking about maximum efficiency or maximum coefficient of performance, that maximum coefficient of performance we would get if your T surrounding is not too low. Okay, so if you have a T surrounding at, let us say, 20 degrees centigrade, and the heat pump operating there, as compared to a case 2 where the T surrounding is, let us say, minus 10 degrees centigrade. So the heat pump here would have a lower coefficient of performance. Coefficient of performance is lower. In this case, the heat pump's coefficient of performance is higher. Okay, so this you will have to understand that the temperatures are important. The second thing is, we cannot achieve too high a temperature in case of heat pump. For example, if you are using a boiler for heating the space, you can have very high temperatures, indoor temperatures for space heating. Whereas if you are talking about using a heat pump for heating application, in that case, maximum you can achieve for central heating is 80 degrees centigrade. Okay, and that too with some efficiency loss. So heat pumps are ideal, that they are more efficient than electric geysers or boilers for space heating, but they have a limited temperature range wherein they can operate. If you try to exceed that temperature, its coefficient of performance falls down drastically. Okay, this is what is shown over here, that if you this is basically to show you the influence of the climate, okay, influence of the climate, outside temperature on the performance. So if you talk about two places, now I have taken the data of USA, two places, okay, where if you have a mild weather, okay, you will find that the coefficient of performance is about 5, okay, and if you have a very cold climate like minus 8 degrees centigrade, then your coefficient of performance is lower, okay. So these two places where you have two different temperatures, you would give you two different coefficient of performance. So the influence, so to summarize, if you have a very cold weather, the performance of heat pump degrades, so the coefficient of performance falls. This can be shown by theoretically by calculating the Carnot COP of heat pump, which is TH upon TH minus TL, and you will know that if your this temperature, okay, if this temperature is too low, okay, then your coefficient of performance would be degraded, okay. Similarly, from this expression you would also understand that if this TH is too high, your coefficient of performance drops down. This heat pumps advantage is that they are relatively easy and inexpensive as compared to the other systems, okay, when you are talking about air to air source heat pumps, okay. They can be sized for your individual homes, okay. They are not used for district systems. For that you require a different type of heat pump. And the advantage of air source heat pump, as I mentioned, is that they can be reversed, okay, because it is basically vapor compression refrigeration cycle. So if you can reverse it and operate it as an air conditioner, because the components remain the same, okay, the only thing is that the outdoor and indoor units would be exchanged, and you can operate these heat pumps in a cooling mode also. So these are the advantages of air source heat pumps. Worldwide, if you look at the data of the air source heat pumps, so about 10% of the heating, space heating applications, 10% of the demand is made by the heat pumps, okay. And because heat pumps are used at least for 10%, that is going to save you considerable fossil fuels. Not only that, that is going to reduce your, because your fossil fuels would be less burned, your greenhouse gases would be reduced. So low greenhouse gas emissions are possible by using the heat pumps, air to air heat pumps, right. If you look at the macro picture of the heat pumps, especially the period where you are experiencing a lot of turmoil, you will find that, for example, because of the war between Russia and Ukraine, there was a shortage of the gaseous fuel, natural gas, which is widely used in space heating applications, okay, in your European climates, European countries, right. And as a result of this, because the Russian gas was basically its flow halted because of the war, and because Europe sided with Ukraine, right, that resulted in basically quicker adoption of heat pumps, because heat pumps are electricity driven, okay. So when you are using heat pumps, you would not require natural gas for space heating, and that way the demand for natural gas, which was coming from Russia, that was tackled by the European countries, okay. So this way that gave them more energy security, right. So if you look at the data, that saved about 13 billion meter cube of natural gas, and so about 14 million homes in that year they shifted to the heat pumps, okay. So you understand that any technology, they are a function of geopolitics, right. If there is a shortage, and because of the politics, it's not the demand and supply shortage, it's basically the shortage inflicted because of some political events like Russia-Ukraine war. You find that some technologies get adopted. So in this case, because of Russia-Ukraine war, in European countries, you find that the heat pumps technology got a boost, okay. The other type of heat pump okay, is ground source heat pump. So we talked about air source heat pump, and we said that this has number of advantages, but another source of heat which can be tapped is the uh, underground energy. And as you see here in this picture, you'll find that beneath the earth's crust, you are basically tapping the energy. So the Q would come from underground. Okay, so that is called as the geothermal heat pump. Okay, and here obviously you require a lot of drilling. Okay, so this is the schematic of how the ground source could be harnessed, right? Here you'll find that basically bore, bore well, no? So bore means holes, right? Vertically you drill, and that is called as a bore. So you basically drill beneath, and you either take the heat from the water, or from the water means aquifer, right, or from the soil, right? And because underground temperatures are much more stable than the ambient temperatures, this has the advantage of better performance, right? So, and you can then extract that heat, store it somewhere, and use it for your heating application, okay, or even for your cooling application for that matter, right? Coefficient of performance reported for ground source heat pumps are in the range of 3 to 6. Okay, so they are more efficient than your air source heat pump, and they are more stable also, because as I said, the outdoor units temperature would be much more stable. Okay, outdoor units temperature, and outdoor units temperature, when we are talking about, we are basically referring to the temperatures beneath the ground, because your heat is being extracted beneath the ground in your ground ground source heat pumps. This is the thing. However, as you understand that because this requires lot of drilling and the stuff like that, the initial cost or the capital cost would be huge, and there would also be some environmental constraints and it's not as easy as your air source heat pump to install a ground source heat pump. So if you look at this, just a comparison between the two, okay, the initial cost will be lower for air source heat pump. The coefficient of performance is lower for a air source heat pump. This is less efficient, but cost is less, capital cost is less. So the performance is moderate, and it is best for individual homes. But for a larger setups, one can look for a ground source heat pump, because for a larger setup the cost gets divided. So the ground source heat pump has essentially a high setup cost, but it has a better performance. The coefficient of performance is far better, okay, and its performance is also stable, because the underground temperatures are much more stable. Okay, so on the performance, if you compare these two, air source heat pump and ground source heat pump, air source heat pump wins on the initial cost basis and ease of operation, whereas the ground source heat pumps, they win on the basis of constant efficiency and a higher coefficient of performance. Okay, so this was about the introduction to the heat pump. I hope you understood this.